Good day, grade 12s. I hope you're all well, and I hope that you are enjoying the sequences that we have done for the last few days. But now it starts to get a lot more interesting. So let's have a look at geometric sequences. Okay, so here we have geometric sequences. Is now the second lesson, but in the textbook, page 7. So just to do a quick summary, we have a general term and how do I prove a geometric sequence. So my general term is a r to the power of n minus 1. The a is my first term. The r is my constant ratio between the terms. So the r is defined as T2 divided by T1, and it should be equal to T3 divided by T2. Okay, so the r, we normally do two calculations to make sure we have the correct r, and also that we have a geometric sequence. So in general, we will say term n divided by term n minus 1. So how do I prove a geometric sequence? I look if I work out all the three ratios here. So if T2 over T1 equals to T3 over T2 equals to T4 over T3, then I have proven that I've got a common ratio. So let's just look at this very quickly. We are still doing a bit of a recap. So let's have a look at the sequence here. I'm just going to move this to focus better. There we go. So my sequence is 5, 10, 20, 40. So the A is going to be the first term. Now we want to see, is this a geometric sequence? So we say T2 over T1 is 10 over 5, that is 2. T3 over T2 is then 20 over 10, and that is 2. So that means this is a geometric sequence, and r is equal to 2. So my general term will then be ar to the power of n minus 1, and say the a is then 5. The r I always put in brackets, 2 to the power of n minus 1. So let's just look at how the terms look like. Term 1 is then going to be 5 times 2 to the power of 1 minus 1, which is 0. So it will just be 5. Term 2 will be 5 times 2 to the power of 2 minus 1. So it will be 5 times 2 to the power of 1, which will be 10. Term 3 will be 5 times 2 squared. Term 4 will be 5 times 2 to the power of 3. So I can also say term 1 is then equals to a, term 2 equals to a, or term 3 equals to a r squared, term 4 equals to a r cubed. Okay, let's go on. Just one moment for me. So let's have a look at our work example on page 7. So what they give us is, it's this one here, work example, page 7. They give us 96, 48, 24, 12. Okay, and the first question is, state the values of the next three terms. So for the next three terms, we don't even have to work out anything. We just look at, we can see this is 96 divided by 2, divide by 2, divide by 2. So you can just do it intuitively without really having to work out the general term. So 12 divided by 2, divide by 2, divide by 2. The next question is determine a formula for the nth term. So firstly, we're going to say A is 96. They tell us that it is a geometric sequence. So we know how to work out the R, that we are going to have a R because it's a geometric sequence. So T2 over T1 is 1 over 2, and then we just test it with T3 over T2, and that also gives me a half. So that means my R is a half, geometric. So I know my general term is AR to the power of n minus 1. And you can just write 96, which is the A. R is a half to the power of n minus 1, and that is my general term. Okay, the third question is determine the value of the 10th term. Okay, so that is pretty straightforward. So we are just going to say term 10, 96, a half to the power of 10 minus 1, which is 9. So that gives me 3 over 16. The next one, which term has a value of 3 over 64? So we have 3 over 64 equals 96 times a half to the power of n minus 1. So now we know, so what we have to do to solve the n, we must make sure we have the n only on the one side of our equation. Okay, so now firstly, so we are firstly going to get rid of this 96. So we are going to say 3 over 64 times 1 over 96. So this is dividing by 96. And here also I'm going to write the exponents separately, which means I can also divide by 2. So here I say times 1 over 2, and now I'm only left with a half to the power of n. The answer here is going to be 1 over 4096, this answer here. And by trial and error, you can establish that 1 over 2 to the power of 12 will give me 1 over 4096. So in this case, the n is equal to 12. Okay, now we do not always want to work with trial and error. You can work with it, but there is another way of doing it. And that means we are going to introduce you to a concept called logarithms. So let's have a look here. Okay, now the logs are on page 49 of your textbooks, but we are not going to do it in detail as they do it there. So I'm going to first, this is the only thing we are going to do basically for this year. So it works like this. When I have y equals a to the power of x. So the a here is my base. The x here is my exponent. Then I can write the x. So I write the exponent equals log, and then the base I write there under the line, And then I just write the third one, which is the answer there, y equals. Okay, so exponent equals log of, and then the base is a, and the y is the only one left. So let's have a look in this case what we are going to find there. So we go back to our question, and here we want to solve the n. So let's have a look. So here I've got my exponential equation. So I've got 1 over 2049 equals a half to the power of n, like that one there. So now we want to write n equals. So the n is the exponent equals log, and then the base is the half here, and the y needs to be written there in brackets. So I want us to look at how do we do this now on a calculator, because you need to be able to do it on a calculator, which I don't have with me at the moment. Sorry, people. I'll show you this one. Let's just, for now, you don't have to know how to do it on a calculator, but I'll show you tomorrow. Let's have a look here. Worked example 2 on page 7. I just want to make sure that I didn't skip something here. Let me just have a look. Now, we did the whole of example 1. So now we look at example 2. So now they give us x's. They give us variables. They tell us it is a geometric sequence, and they say solve x. What is the value of the x? So we know that for a geometric sequence, we have a common ratio. So the r is going to be 2x minus 6 divided by x minus 6. And that will be equal to 5x plus 3 over 2x minus 6. Okay, now in this case, we are going to simplify it further. So we are going to say 2x minus 6 squared equals 5x plus 3x minus 6. We multiply out and we get a quadratic equation, which we are going to factorize. And now we get 2 answers for x. So that means 4x minus 6, 2x minus 6, and 5x plus 3, the x can be 9, and it will be a geometric sequence, or the x can be minus 6, and it will be a geometric sequence. So this is mostly the case when we work with geometric sequences, when we work with variables. So we have 2 sets of sequences. So let's have a look at question number 2. So question number 2 looks like this. It says, so there's my worked example 2, there's my sequence. Number 2 says, if x is 6, state the first 3 terms and the nth term. So let's have a look. So for x equals 6, then what I'm going to do is I'm going to substitute the x in here. So I'm going to have x minus 6, so that means minus 6, which gives me minus 12, 2x minus 6, which gives me minus 18, and 5x plus 3, which gives me minus 27. So those are then the first three terms. Okay. So for us now to work out the general term, we're going to say that A is negative 12. The R is going to be minus 18 over minus 12, which gives me 3 over 2. And we just do a double check, minus 27 over minus 18, 3 over 2. So the R is definitely 3 over 2. So my general term, A R to the power of n minus 1. So now the A minus 12, the R must be in brackets 3 over 2 to the power of n minus 1. I want you to make sure, can you see why I put this minus 12 in brackets? Just to make sure that you understand that the sign is the sign of the 12. It's just easier to read if you put it in a bracket. Now we're going to do the same for x equals to 9, which is basically same as we did there. We substituted the x 9 minus 6, which is going to be 3, 2x minus 6, that's 18 minus 6, that gives me 12, and the third term is then 48. So the A is 3, the R is 12 over 3 equals to 4. Just double checking, 48 over 12 is a 4. So that means my general term, and I substitute 3 times 4 in a bracket to the power of n minus 1. Okay, and I've written here, note that this question leads to 2 geometric sequences. So you've got this sequence here, and you've got that sequence there. And it is all because of the R, that is term 2 over term 1, term 3 over term 2, that we then normally get 2 examples. Okay, so I'm going to stop now. Tomorrow we are going to do a very nice exercise on algebra, so pertaining to this question. So your homework is then going to be exercise 3 on page 8. So it is on the next page, a small little exercise here. Okay, it's not a lot, but I want you to make sure that you get it exactly right. And I want you to check the answers. You have to check the answers at the back of the book. You have to mark the answers with a pencil. So you take a pencil, and there, for example, I've worked out an exercise and I mark it with a pencil. Now, the reason why we mark it with a pencil is that when you prepare for the exam, you can immediately see this question did not present a problem to you. And we can rather concentrate on the examples that you did not get right. Also remember, if you want me to give you, I want to see you doing it 3 times, trying it 3 times before you tell me, ma'am, I did not know how to do this. I'm going to talk to you again tomorrow morning. Enjoy the exercise. I'll talk to you again. Okay, let's do this.